Alright, so we've got these two towns, two towns. So A, town B is somewhere in the middle, town C. Alright, so let's make this distance between A and B x1 and this distance between B and C x2, and the time it takes between A and B is t1, the time it takes between B and C is t2. So u is the speed between A and B, and V is the constant speed between B and C. Now, the first thing we're going to talk about is prove that, so if x1 equals x2, so B lies exactly. So if x1 equals x2, then the cyclist's average speed W over the total distance AC is the harmonic mean. All right, so when we're talking about the W, the average speed, we're saying speed equals distance. So total distance over the time, and we know that x1 and x2 are the same. So let's just call them both x's. So this is what we're looking at here. All right, and we're going to prove that they equal harmonic mean. Now the harmonic mean is h, where 1 on h is the arithmetic mean of 1 on A and 1 on B. So the A and the B being the U and the V in this case. So if I just look at the arithmetic mean of 1 on U, 1 on U plus 1 on V, so the arithmetic mean would be, I add those together and divide by 2. Now when I do that, if you think about it, you've got V plus U on UV divided by 2, so times by half. So that would be V plus U on 2UV. Right, this would be our 1 on H. And so we're required to prove that our W is equal to H, which is equal to, this would be this reciprocal of this, equals that. All right, so let's see if it does. So far, this is what we've got. But do remember, so if you think we're trying to head to there, we just want everything in terms of U's and V's. So if I rearrange T1, I get x1 on U. So let's just put divided by, I'll put that there. So T1 is x1 on U, and T2 is x2 on U, on V, sorry. All right, so let's go from there. So I would multiply by the reciprocal. Now that as a fraction, if you think if I make a common denominator of UV, I've got Vx1 plus Ux2. So if I now times, I'm timesing by UV on, and sorry, remember that the x's are exactly the same because x1 equals x2. So let me factorize by the x there. So you can see the x's will cancel and you'll get indeed 2UV on U plus V there, which is what we were required to show there. All right, so then let's pretend now that these two towns are not equidistant, or sorry, B, didn't mean to rub that out. So this time B does not lie exactly in between, it lies in between, but it's not. X1 and X2 are no longer the same distance. So remembering that's X1 on T1 and V is X2 on T2. So now suppose the distances A, B and BC are not equal. Show that W, so again W being X1 plus X2, so the average T1 plus T2, speed across from A to B. Show that W is the arithmetic mean of U and V. So what's the arithmetic mean? So it's show that, if it's equal to the arithmetic mean. So let's make it equal to the arithmetic mean, which is just U plus V on 2. If that is so, we should be able to prove this. Now remember, AB is X1 and BC is X2. So really I'm looking to get X1 on X2 and U's and V's. So this is what I want to end up with. All right, so again, I want to get rid of the T's here. So let's have a look at doing that. So if I say I've got X1 plus X2, and instead of T1 again, I'll rearrange this and make that X1 on U and this can be x2 on v. Alright, and that's got to equal u plus v on 2. Alright, so x1 plus x2 will equal u plus v on 2 times... Alright, so let's make a common denominator of uv there. So this will be vx1 plus ux2. So just bringing these brackets across and making a common denominator. And you'll see on the bottom there you've got 2uv. So what I'm going to do is just times that across to the left hand side. So I've got 2uv, I'm going over here, sorry, 2uv lots of x1s and 2uv's lots of x2s. And then if I expand out these two brackets here, I'm going to get uv x1, I'm going to get u squared x2, I'm going to get a v squared x1 and a uv x2. So if I put all the x1s on, let's say this side, so I've got that 2uv on this side, and then I'm going to bring over here, this one over here, so that's, whoops, minus uv, and this one as well, so minus v squared. And then if I put all the x2s on this side, I've got the u squared, this one, I've got the uv, and then I'm bringing this one over here, so minus 2uv's. So now what I can do is keep that x1 but divide by the x2 from the other side. And I'm just going to simplify this, which would be u squared minus uv. And then simplify this and divide it. So this is going to be minus v squared plus uv. Alright, so if you think about it, this is u minus v factorised by u, that is. And if I factorise by v, I'll take this term first, it would be u minus v. So these cancel, and I will get x1 on x2 equals u and v. Therefore, x1 to x2, or ab to bc, equals u to v. Alright, so just rearranging to get the x1 on x2. So if you think about it, again, if I do, see if I can save some time here. So if I do pretty much the same thing, I mean, both of these you can actually do by observation. You might be able to pick it straight away, but if you can't, you just use your algebra. So this time, if you think about what we want x1 on x2 to equal the square root of u on square root of v. Alright, so this time what are we given? We're given that w is the geometric mean of u and v. So geometric mean means this is going to be equal to uv. That's the geometric mean. So again, I'm going to do the same thing here. If I times across and make a common denominator, or I should make a common denominator first here. So I'm going to have x1 plus x2, and here common denominator would be uv. So I'm going to have vx1 plus ux2 there. So if you can kind of imagine, I'm going to times this across. So the vx1 plus the ux2 is what I'm timesing across. And then if you take this one to the power of a half, this is to the power of 1. So in the end, I've got to the power of a half at the bottom. And that I'm going to multiply across to, well, by both sides, but over there. So I'm going to get square root uv of x1 and square root uv of x2. And on the right hand side, I'm left with my vx1 and my ux2. So again, if I put all my x1s on one side, I've got the square root of uv minus v, and all the x2s on this side, I've got u minus square root uv. So I'm back to my x1 on x2, which is what I want, and you can see you have u minus uv, square root uv on square root uv minus v. Now that doesn't quite look like what we want yet, But how about we rationalize the denominator? So we'll times both top and bottom by that. So now what do we get when we do that? So multiplying out this top. Okay, so you get a uv from that term, and you'll get from these terms, you'll get minus uv, so that's great, they cancel. Then you're going to get a u square root uv from that one, and then from this one you're going to get minus a v square root uv. On the bottom it's difference of two squares, so square the first, you will get uv, minus square the second, you will get minus v squared there. Alright, so of course these cancelled, and if I factorise by square root uv, you've got u minus v on top, and if I factorise by v, I've got u minus v on the bottom, so those now cancel. And then if you think about it, now that I've run out of room, I'll just have to write it here. So if I write the square root of u, so then you've got square root v on v, which is the same as square root v on the bottom, right? Use maybe index clause to help you. There. So you can see now I've got x1 on x2 is the square root of u on square root v, which means ab to bc is square root u to square root v.